Hi, my name is Isma Wali. I am a PhD student in computer science. I, with a group of other students, work on a project on comparing gender bias across human languages under supervision of Professor Gina Matthews. Today, I'm going to present an aspect of that project that discusses issues regarding building corpus of the classic books in 8 human languages. I'll start with a brief introduction, then some background and previous work, the methodology we adopted for the project, and then I'll discuss in detail process and challenges faced during building and processing of our book corpus, and then conclude the presentation with some analysis and suggestions. Natural language processing plays an important role in critical decision-making systems that are applied to almost all fields of life. These decisions mostly rely on NLP-based recommendations and have a high impact of human lives. For NLP-based decision-making systems, it's common to use pre-trained models to save time and effort. But the biggest question arises here is whether these NLP tools or the pre-trained models support every language. This is what we try to find out with the case of the corpus of classics. Some experiments were performed with the pre-trained models on the data sets that are based on English Wikipedia of 2,500 million words of book corpus and a book corpus of 800 million words and the corpus of Google News. Gender bias was calculated on these data sets. An important point to note here is that all these data sets are based on English language. One of some of our previous works is from Bologbasi et al.'s work that used pre-trained models of word2vec on the corpus of Google News to calculate gender bias and discovered that NLP systems can learn bias from the corpora of text on which they are trained. The second work quantifies the direct gender bias on Wikipedia and book corpus using BERT's pre-trained model and fine-tune it with the glue benchmarks and recorded significant results regarding the gender bias. Based on English versions of Wikipedia of 2,500 million words and book corpus of 800 million words, we decided to build similar data sets of Wikipedia articles and a book corpus of classic writings for 8 languages written originally in that same language. Next step is to convert those corpora into the text form. After converting, we quantify the gender bias using pre-trained BERT model on the above corpora, and the results will be used for future predictions. So I will be talking about first 2 parts focusing on one aspect of our project that is related to corpus of classic books for 8 human languages. And we'll also be evaluating NLP toolchain support for the NLP pipeline. When we analyze the book corpus, we did not found any problems assembling and processing corpora for some languages like English. However, we started facing challenges for other languages even from very start of the process. For example, for Arabic and Urdu, we found many texts available as scanned images rather than the text format. As a result, we use OCR to convert these images into text with wide range of accuracy rates between 70 to 98%. But we also observed that the OCR to make these conversions can be problematic in any language. For example, in Chinese, we observed that OCR incorrectly added space every time a new line began. We also observed many wrong characters after the conversion. Another challenge we faced for some languages like Wolof that does not have a character set of its own. Rather, it uses text versions of the English, French, and Arabic characters. As a result, some same language could be transcribed differently in different character sets. So other than the challenges discussed, we also evaluated NLP toolchain support for these data sets, and we found disparities among languages and discovered that some languages have full NLP toolchain support throughout the NLP pipeline and many do not have this support. We also observed that And the provided support is even spottier when it comes to accuracy, reliability, and availability. After evaluating the data sets and the tool support for 8 human languages, we observed that not every language has access to NLP toolchain support for NLP pipeline. NLP guided decisions are still underrepresented many languages, and substantial caveats remain to prevent full participation. Lack of representation in early stages of NLP pipeline is further magnified throughout the NLP toolchain. So at last, we suggest improvements to overcome the disparities among the human languages to have full and equal access to resources. Thanks for listening.